Hey there, this is 814, and we're going to talk about box plots and interquartile range. The first start of this lesson will be stuff that will be much more of review, and what it's going to do is hopefully try to prove that some of our old methods aren't necessarily their best methods. And so what we're going to see is a new way of plotting things is what we call box plots, and in part of those box plots is interquartile range. So that'll be kind of our focus today. I'm not going to read this opening part, which you could do on your own. So let's get started. This 844, it says, is the planet getting hotter, right? Under this thought of climate change that we've recently, much more recently discussed, right? Experts look at the temperature of air in the oceans, the kind of molecules in the atmosphere, and many other kinds of data to try to determine how the Earth is changing. However, sometimes the same data can lead to different conclusions because of how the data is represented. So let's take a look at some of that. So here what we have is we've got a resource page, which I've kind of listed and shown all below, on November 1st, 1975, and from November 1st, 2000. To make sense of this data, you'll first need to organize it. So what we're going to do is I'm just going to show you that we have a bunch of cities there on the left. On the middle column here, we have... so we've got all those cities, and then here we have 1975's data, and we have 2000's data. If you take a look at that, the 2000 data is in order, and that in order data will become useful here in a little bit. 1975 is not in order, but I do put it in order for you later on, which will become obviously very useful too. So what you can see here are all those lists of cities and those temperatures. Progressively, they should be getting warmer as we move along, and as you can see, we have a total of 35 cities that we've taken. So normally I'd give you guys two sticky notes. You would choose one city like New Orleans, and then you would put on our this histogram and where the 80 and the 86 would go. But you guys can't do that, which kind of stinks. So what we're going to do is we're going to just quickly create the histogram. And what I did is I kind of color-coded some of the data over there to the right to help us figure out how to plot that. So in the histogram, Anchorage is our first one, and it's 13. So if we have a frequency, what we could do is we could just put, what's our highest number? 11. 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. And we'll just plot that quick. So what was that first one again? First one was Anchorage, and it was 1. So we would just fill that part in right here, right? And then we would move over. Yeah, we have a 29 for Juneau. And Juneau, I didn't even tell you this. I apologize. All that data is organized in the right, and by that organization meaning that you can tell that it's not the same as up above because all these numbers that were in front of that have changed order. It's been much more about the 1975 temps, and these temps are in order there. So that becomes extremely useful for our 1975 data. I apologize, I kind of jumped ahead there because I knew I had done that. So Juneau, 29 degrees. So we'll go under the 20s, and it was just a 1, right? Then in the 50s, we have 9 of them. I counted them out ahead of time. Please correct me please don't make the same mistake if I happen to make one, right? So what we'll do is we'll go under the 50s, and we're going to go up 9, right? So 1, 2, 3, 4, 5, 8, 9. I think I got that right here. There it is. So we have 9 of those. Under the 60, we have an 11, right? So we'll go just a touch further. And in the 70s, we have 9 of them again. So we're going to go right up there, right? And then in the 80s, we have 4. Something like that, okay? So that's what our histogram would look like for the 1970s, 75 version. And what I'm going to do is I'm going to go ahead now and we'll continue on. What do we got? Let's do it now for the 2000s, right? So on the far right, this data is in order. If you recall, the original data was already in order. That's why those numbers that were there are in order. So this is the 2000 temperatures in order. So let's go ahead and fill those in. Notice the first one was in the teens previously. This one's in the 30s. So the colors don't necessarily match the same type of values, right? All right, so let's move forward here. Let's go to 30 degrees. We have one. Whoops, I should mark my left side here. 7, 8, 9, 10, 11. There we go. And we had one in the 30s, so let's mark that one quick. And let's move to the next group. We have 4 in the 40s. And in the 50s, we have 7 of them. Hopefully I did that right. 1, 2, 3, 7, yep. And 11 in the 60s. 8 in the 70s. One more than what we had in our 50s, right? And we have 4 in the 80s. All right. Okay. So there's our data there. Notice again as we just kind of glance back and take a look. The purple, the red, the yellow, and the greens will match up above, but the blues and the blacks do not. So we'll move that real quick. So okay, take a look. Okay. All right. So which one's hotter, huh? So how many cities were measured for this study? Well, we already had talked about earlier that there were 35 cities for this, right? Describe the spread and shape of each of the histograms that you've created. Which measure of central tendency would you use to describe the typical temperature for each year? Justify that choice, right? So, apologize, I'm trying to get some other information that I didn't have in front of me. So let's go back up to the 1975 stuff. What does this look like? It does look like it is a single peaked. We can put that down there. It does look like it's single peaked. It comes up and then just comes down. And I would call it, it's not symmetrical really, is it? Mostly because of these guys here, right? Not symmetrical. Being symmetrical, right, is that mirror sort of thing. What we would call it is asymmetrical. I'll make sure I get that right. Asymmetrical is meaning not symmetric. Okay, not symmetric. Let's take a look at this stuff. Also single peaked, isn't it? Yeah. It also looks much more symmetric, doesn't it? It kind of looks like there's a mirror there on both sides of the yellow. It's not perfect, but I would call it symmetric. So when we take a look at this data, I think I would say that everything is safe to probably use. Let's go back down here. So describe the spread and shape of each of the histograms. We kind of wrote that above. I guess I won't rewrite that for you. Which measure of central tendency would you use to describe the typical temperature for each year? I think for 1975, I'd probably use the median. And why would you use that, Mr. Krohn, right? Well, if we take a look at this data up here, I think the reason I'd use the median and not the mean is partly because of like Anchorage and Juneau. Look how far away those are from the rest of our data. That's quite a bit. So I'd really probably lean much more on a median than a mean because those are my outliers, right? So in here, That 33 is pretty far away. You could say that a median would be a better choice. A mean isn't too bad either. It's a little bit different than having those two data points far away in 1975. So I'd say median probably. And then in the 2000 data, I'd probably say you could use the median there too. If you use the mean, I think that would be all right also. I don't think that would be too bad. And I guess I kind of gave you that verbal justification for that. So we did look at the graphs of the temperature. According to these histograms, what can you say about the temperatures in 1975 and 2000? Do the graphs show that one date is warmer than another? Are the temperatures basically the same? Again, could you say that that is warmer or not warmer? Boy, that's hard to tell. There seems to be much more like green and red, isn't there? Yeah, more greens and reds, which makes it feel like 75 could be warmer. But, 1975 had data that was way over here, too. It's kind of a hard check, right? And that's the whole point, right? It isn't easy. Kind of hard to tell, right? It's not an easy thing to do. You could easily argue both of those back and forth. In 1975, right, the peak temperatures were 80 to 84. I guess that's about the same. 82 to 86, that's about the same. Not a ton difference. They really are hard to tell. So what we're going to do is we are going to create what's called a box plot. Okay, and we're going to need to find quartiles. Quart, right? There's 4 quarts to a gallon. 4 quarts to a gallon. And what we're going to do with our data is we're going to break it into 4 parts, just like 4 quarts breaks up a gallon into 4 parts. All right, so what we have is we have all of the steps written down here. I'm going to not read those steps, but I'm going to take you through those steps down below. So what I'm going to do is, first what we're going to do is we're going to label on this number line, we're going to put this box plot on. And the first thing I want to do is make a couple of vertical lines. Actually, I'm going to make 5 vertical lines. 5 vertical lines. We can label those lines as we go through this, and then we're going to make some horizontal lines. And this sounds really hard or difficult, but the horizontal lines are just to make it look like a box. All right. So I have all the data here for 1975 to put my box plot together. And what I'm going to first do is I'm going to choose the, what would be the best? The minimum value, right? The minimum value for that. 63, hold on, I'm checking something here. Yeah, that is right. Okay, so we're going to use that minimum value right here. All right, I already, that'll be one of our lines that we're going to put on there. I already have another line figured out for you guys. It's the median right there. That's the middle number. And then I have the maximum value here. So let's put those on there. Maximum value is 84. Median is 63. And the minimum is 13. So 84 for our maximum. So we go over to the 84 and we're just going to make a vertical line on 84. Our minimum is 13. Let's go to 13. Let's make a vertical line. Not perfect, but it's close. And our median is 63, right? Kind of hard to do on this process. There we go. So let's put, I'm going to label these to help us see this. It's our minimum here. And by the way, it is equal to 13. We have our median here. And our median in this case was 63. And the max was 84. There we go. Okay. I don't have to have the numbers on. I just put the numbers on to help us kind of see that stuff a little bit easier. All right, so we actually have 3 of the 5 vertical lines created. So now what I need to do is I just need to do the median 2 more times. That's really weird, isn't it? But here's what I'm going to do the median of. I'm going to do the median from here up. I'm going to do the median for that up. So how do I do that, right? Well, actually I have 17 values up there. 17 values, and the middle number will be the 9th value right here. And how did I find that so stinking quick, right? Well, when I know that there's 17 and I'm going to take out this middle number, well, first I notice 17 is an odd number. So if I have 17 and it's an odd number, I'm going to choose one number to be kind of in the middle. Again, where this is me finding the median. That means that I'm going to have 8 above and 8 below. Look how that 8 plus 8 plus 1 gives me 17. So what I know is I know I have the middle number here. So the 9th number at New York is what we're highlighting right here. This is what we call the first quartile. Okay, it's the first quartile. All right. So we're going to move down, and we are going to, that arrow's been bothering me ever since I put it on there. I want it to look a little bit nicer, right? There it is. So we are going to find now the median of this bottom area right here. Again, it's going to be the exact same part as the top. It's going to be the 9th value down. So we have 8 values, then we have another value, then we have 8 values down below that. And that one's going to be the 8th value, I could count them down, will turn out to be Kansas City. And what we call this is our third quartile. All right, remember I told you a quart, right? 4 quarts to a gallon. Here we go. This would be, let me choose let's choose a fun color here for a second. A little green, I like that. Right, here would be our first one. First quart, our second quart, our third quart, and our fourth quart. Right, that's like just us breaking all of this into 4 nice pieces, okay? So we are just, basically we're saying, hey, we have all these numbers. Let's divide them into 4 equal piles. This pile gets 8 numbers. This pile gets this, and we just move our way all the way down until we have all the numbers, okay? So now let me graph those on there. In fact, I'm just going to keep it as this green so that it kind of shows that. So first, now I'll use the black. First quartile is 56. Let's come back up here. 56. Oh, no, I apologize. That's a pain. Let's come back up. 56 is what we would call our first quartile. Oops, tile, and it was 56. Okay, let's go down, and 73 is our third quartile. So let's go up to 73. I am frustrated. Sorry, it's super hard to put this in this right here. Whoops. Sorry about that. That's our third quartile. And it is 73. Okay, so there we go. I told you we had 5 vertical lines. We have our 5 vertical lines. Now we need to put in 4 horizontal lines. Here you go. Are you ready for it? The first one goes from the minimum to the first quartile, middle to middle. Whoops, that's not exactly middle. Trust me. You know I'll try this again and it won't work perfect, right? There it goes. We're going to do the same thing from the third quartile to the maximum value. Okay, there's 2 of my 4 horizontal lines. The next 2 horizontal lines create my box. That's it. That right there is a box plot. Okay, so what I've done is I've taken all these numbers, divided them into 4 piles by finding medians and more medians. I've given them all kinds of crazy special names. First quartile, third quartile, all that stuff. but it's really not that hard. It's not that crazy. And what I've done is I've put those all in here. Now, notice on my number line, though, they don't look equal, right? They don't look like 4 equal piles of numbers, but down here we know that all those numbers are equal, right? So what I could really say is, just so we're kind of aware of it, here, 1/4 of all of my numbers, 1/4 of my numbers live there. Another quart of my numbers live here. Another quart. You know what? I actually have a better idea. Let us show these down here. Here's all these purple numbers right here, right? That's those. The next group are all these blue numbers. Let's go ahead and label those the blue numbers. I didn't mark the first quartile in the median, right? Let's do red for the next, right? That's the red. So let's do that. That's all these numbers here. And last but not least, let's go ahead and make this one green. That's all of these numbers right down here. Whoops, I went just a touch far, didn't I? There they are. So what I've shown you is that all those purple numbers fit somewhere in there. I don't know exactly where they are, but they're there. All the blue numbers fit in that part. All the red fit in that one part, and all the green fit in that part. So we have 4 parts that we've shared evenly, even though they don't show up there, okay? So this is called, again, a box plot. It has all kinds of crazy names to it. Don't let the names intimidate you. This down here will show you, again, all of that stuff. The one thing we didn't talk about is what we call the interquartile range, the IQR. Usually don't even say that. The interquartile range should be, let's label that in, let's do an orange. This right here is from the first quartile to the third is the interquartile range. Okay, man, we got a lot of fancy names for all this stuff, which makes it totally harder to remember, right? That is called the interquartile range, and it's just all the stuff that falls between the first quartile and the third quartile. Boy, nothing like picking up a lot of vocabulary in a little bit of time. Sorry about that. So we did talk about the box down here, and now just a reminder on our homework, that our homework here, that I encourage you to work yourself to the proficient and robust area by showing your work. Show that work. Show me that you've made some mistakes. Show me that you've done different stuff to really help me out. Okay, have a good day.